Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight we're really excited to be bringing to you the newest update to the TI-Nspire platform, and that's going to include Python. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're joined by two Python experts, John Hanna and Steve Phelps. John is a retired teacher from Hopac, New Jersey. He taught mathematics and computer science for 35 years at TNEC, New Jersey High School, and is a longtime T-Cubed instructor with lots of frequent flyer miles in the bank. These days, John gets his kicks learning Python, supporting TI's product development team as a beta tester, writing new programming materials, biking every day, and walking on the beach. John, it's great to have you with us.
Thanks for having me, Mike.
And Steve, a longtime geometry, statistics, and computer science teacher, is currently an instructional technology consultant at the Hamilton County Education Service Center in Cincinnati. Steve is a T-Cubed national instructor and co-author of Advanced Quantitative Reasoning, Mathematics for the World Around Us, presenting quantitative literacy, statistics, and modeling as an alternative to the traditional high school senior math courses. Steve, thanks for being with us tonight.
Thanks, Mike, and welcome, everyone.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to John or Steve using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate at the top of the WebEx menu and choose Audio Broadcast. John, you're getting control. As a reminder, feel free to share your screen.
Thanks, Mike. Everybody can see my TI-Nspire software, I hope?
Looks good to me.
Okay, thanks. And we're not going to talk about this program, but with a flick of a switch, we can see our title slide. Welcome to the Python world on the TI-Nspire CX II. First, a big hats off to all those active teachers out there struggling through this challenging year. I got to give you guys a lot of credit because I'm sitting here in a recliner 7 days a week, 24 hours a day, just watching what the world is going through. So hats off to you guys. We're talking about Python on the TI-Nspire CX II. Another flick of the switch. Our agenda for tonight is to get you acquainted with the environment. The ecosystem that's built into the CX2 now includes Python programming. So we'll take a little bit of a look at the editor and the shell, some of the menu features that are built into the system, and then we'll get into some programming later on as live examples of what you can do with Python very easily on the TI-Nspire, because the TI developers have done a remarkable job of making this student-friendly for middle school and high school students. So we'll talk about the editor and shell for a minute. Steve, feel free to pipe in whenever you feel like it. This is the editor, and the first thing that pops out to you is the color enhancements in the editor, unlike the TI Basic editor, which also, by the way, does have color too. But you'll see some blue, some red, some green on here, as well as the light gray comment at the top of the screen. The editor's menu consists of all kinds of programming features for the Python environment. The first few menu items up here are about the file itself and editing. And then the rest of the stuff down the rest of the menus here is all about the programming commands that you can incorporate into your code. One thing that will be familiar to you is this run menu, because they've made this very convenient for anybody who's accustomed to TI Basic programming. There's a Control R key, shortcut to run this program, and a Control B key to check the syntax and save the file. We'll skip the rest of these stuff for now because we'll actually be using these menus when we start writing programs. The shell, however, is the second page in this document. By the way, you'll be getting a copy of this file, a download link after the session is over. You'll be able to download this actual file in its current state. And we'll also be providing a handout, a 7-page PDF file of introductory materials for Python programming on the CX2. The shell has its own menu as well, and it looks very similar to the editor shell. This is because all of the commands that are on this menu can also be incorporated into the shell, but they would execute immediately rather than be stored up into a program. So all of the stuff that you see in the editor is also duplicated in the shell because the shell acts like the calculator app. If I type something like 2 plus 3 and press enter, it evaluates that expression. It's a live calculator processor, just like the calculator app acts for the basic programs. Modules. Going back into the editor, the first few modules in here are the built-in things that are available for standard Python programming. And this is where you'll find your if, then, and else statements. Whoops, I'm sorry I did that. Let me put that back again. Built-ins, control. There we go. So on the control menu, just like in BASIC, you have the if statements, the for loops, and the while loops. And that's all that there is to control structures in Python. On the functions menu, I'll be using this one in a moment. You'll be able to define a function, which is highly popular in the European classrooms. On the operations menu, you'll find all of the assignment operator, the relational operators, the logical operators, and down at the bottom, the 2 Boolean values, true and false. And we're not going to go through all of these menus, but just giving you an idea of all the features that are loaded into this menu system. You might see more modules down here. That's because the developers did not want to make the menu too long. So they created a submodule with some more modules down here. Some of the modules begin with the letters TI. Those are the modules that TI has developed specifically for this platform to make it do things that ordinary Python flat programs can't do. If you're a Python programmer, you may recognize the TI plotlib commands for plotting graphics. And you can do that right within a Python program. You can do graphical programming. And these commands are not to replace the Graphs app in the TI-Nspire, but to allow you to create graphics within a TI-Nspire program on the fly. So let's get started with writing a program so that you can see how these menus actually work. But before we do, I want a little word about programming. I found this on a European webinar. It's okay to fail. And that is, if we're not making mistakes, we're not learning anything. And if we focus on those errors, this happens to me all the time. It's the errors that help me get a good program going. And I don't worry about making mistakes because the computer doesn't yell at me. A learning process, and don't ignore those errors, focus on them. My project, my first program for the casual user is Heron's formula. I'm going to write a program that will let us enter the 3 sides of a triangle and calculate the area of the triangle based on those 3 sides. If you're not familiar with Heron's formula, we first have to calculate the semi-perimeter, or half the perimeter, and then calculate this square root function over here to produce the area. A word of caution, though, on the TI-Nspire, this screen can calculate the area, either by using the menu. This is a geometry app, so I can go to measurement and calculate the area right away. Or I can create values for the three sides of the triangle and then calculate the two expressions on this page and get an area that way. But we're talking Python. So I'm going to hit a new page and get rid of the code that I wrote here earlier. Let me delete this, okay, and delete that and start from scratch. New page, Control-I to get a new page. By the way, I hope you're not trying to keep up with me here because I'm going to go rather quickly. Remember that this is being recorded, so you can play it back at your own pace. Down at the bottom of the TI-Nspire new page menu is the Add Python feature. And we're going to create a new program. The name of the program will be Henon, H-E-N-O-N. We'll not worry about the type yet because Steve will take care of that when he does his demonstration. And hit the OK button or press the Enter key. And it brings us into the Python editor. The name of the file, and this is actually a Python file within the TI-Nspire document, the name of the file shows up at the top of the page, and the two numbers on the right are the line number and the total number of lines in the file so far. On the menu, since we're creating an area function, we're going to go to the built-in menu, select Functions, and choose Define Function. It's important to choose these things off the menu because when it gets pasted into your code, it includes inline prompts. The word function, the word argument, and the word block are placeholders for you to replace with your code. Pressing the Tab key lets me jump from inline prompt to inline prompt and easily make changes to each of those things. So for the word function, and by the way, this word function is not editable. The cursor jumps from the beginning to the end of the command. It's got to be replaced with my word. So the name of my function is going to be Henon, H-E-N-O-N. And yes, it conflicts with the file name, but they don't even look at each other. For argument, we're going to use the three variables that represent the three sides of the triangle. In my drawing earlier, I had A, B, and C as the three sides of the triangle. So I'm going to stick with that convention, A, comma, B, comma, C, as the three arguments to this function. Press the Tab key. And now here's where I have to actually write my code. The code is going to first calculate the semi-perimeter, as you saw on the earlier page. That was the letter S. For the equal sign, you can press the equals key on your keypad. And then we're going to type 1/2 by typing 1 divided by 2. And then in parentheses, A plus B plus C, and close the parentheses. And press the Enter key. By the way, you notice the two spaces in front of the letter S. This is automatic indenting. And these are actually spaces, but they have a little diamond in front of them to let you know actually exactly how many spaces are there, because indenting is crucial in Python programming. Instead of using things like curly brackets, like C++ or Java, or begin and end like Pascal, Python just uses indents to indicate blocks of code. The second expression is to calculate the area. I would like to write A equals, but A is already being used as the side of a triangle. So I don't want to interfere with that variable. So instead of A, I'm going to use area, A-R-E-A, equals. Now I want the square root operation, but I don't have one in Python yet. We'll talk about that later. So instead of using a square root function, I'm just going to use parentheses, S times parentheses, S minus A, another multiplication sign, times S minus B, close parentheses, another multiplication sign, and S minus C, and close the parentheses twice, once for the S minus C and once for the entire expression, and raise that. I'm going to hit the caret key here to raise it to the 0.5 power. Caret, however, produces two asterisks. Instead of a caret symbol, Python uses the double asterisk as the raise to power symbol, and we'll raise it to the 0.5 power or the 1/2 power. So every function needs a return statement. It calculates something, it has to send it back to the original program. In this environment, we go back to the menu system, down to built-ins. Under functions, there's a return statement. Paste that into the code, and we want to return the area to the calling program. Hit enter, and you notice that the two spaces are still showing up as the indent operator, but they don't really mean anything. We can get rid of them. They don't mean anything to the code, but the block of code is now finished. Yes, I can type in return by hand. Everything here that you see could be typed in by hand, but I caution you to, if you know what to put into the code, if I type def henon, I would not see the word function, the word argument, and the word block if I don't choose it off of the menu. Also, if I delete this text up here, the word function does not come back. It's only a one-shot. As you pick it off the menu, as you replace it, it does not know to put it back again. So it's advisable to pick things off of the menus. This program is typically, this is the way that the Europeans would leave this program. If I press Control-R to run the program now, it pops me over to the Python shell, which is the next page. Page 1.7 is my program, and page 1.8 is a new shell that's been inserted into the file. And in this shell, I can press the var key on my handheld, find the function henon, and give it some values. So I'm putting in A is 3, B is 4, and C is 5. Press the enter key. Whoops, I got a mistake. What's going on here? Int object isn't callable. What went wrong here? Can anybody tell me? I'm waiting for a comment. Look at where my cursor is. I left out the multiplication sign. Try that again. Press var, henon, 3, 4, 5. Thankfully, I get a 6. So the henon function is working properly now, and I can write a program now around this function by adding some code down below. But I think I'm going to pass the torch to Steve, and then if we have time, I'll come back and show you how to write the input statement here and the print statement, which are also on the built-in menu. Under I/O, you'll find print and input statements in the Python language in here. The input statement is especially tricky to use, however, and we'll come back to that in a moment. So, the functions are a big part of Python. They can produce values, but they can also act as subroutines in your code. I'm going to pass the torch to Steve, and he's going to talk about some of the other modules in here. Assign Steve.
Thanks, John. Thanks, John. This is awesome. Python's awesome. There's the ball. I get the ball that comes back to me. Fantastic.
Phew, I made it.
I think we're, let's see. Let me back up a couple pages. Let me back up some pages. There you go. So here's what I would like to do is I just want to kind of maybe give you some ideas about how you could just easily incorporate this into your classes. And And so this is my scenario. Here is my scenario. I've got this unit square, and I've got some random points in this unit square. And so as I click on my slider, these random points hop around, and I have that segment that's connecting those 2 points. So help me out in the chat for just a moment. In the chat, what kind of questions would be worth investigating about this scenario as I happen to kind of bounce the random points around the screen? If you'd put that in the chat for me, man, that would be awesome. A little audience participation. Will there be no audience participation in the chat? Oh my gosh, what would you like to know about that segment?
Well, thinking. The brains are ticking. I can smell it.
How long is it? Slope. Oh, you know something? Slope would be good. So let me ask you this question. These are the kinds of things I would probably pose to my students in my class. What is the longest this segment could possibly be if each side of the square is 1 unit long? What's the longest average length? What's the longest that this could be? Root 2, and I agree, square root of 2, and then what is the shortest? I got to ask it, man. I got to ask it. What's the shortest that this segment could be? Yeah, I'm going to assume 0, 2. I mean, that would occur when the 2 points are exactly one on top of the other. So I'm thinking that these 2 points, if that segment is like or if the points are on opposite vertices of the square, I'm going to get a square root of 2. But if they're one on top of the other, I'm going to get a length of 0. And so let's write a small, short little script or a program in Python to capture that. So the things we need to try to do is we need to generate some random coordinates. So we need to generate 2 random x's and 2 random y's to do that. And then to find the distance, we're going to need to use the square root of something. And I would like, as I think someone might have been Jessica said, that what's the average length? I'd like to print out the average length of all these segments, as well as I'd like to export all of these different lengths that these segments occur. I'd like to export them into a list and graph them outside of Python and graph them in a dot plot in a data and statistics page. So I'm going to go ahead and I'm going to add a page. I'm going to go Control Doc, and I'm just going to add a Python page. I'm going to go Python new. Let's see what happens, and let's call this. I'll just give this segments. That's what I'm going to call this, segments. I was a teacher technique. I'm not going to do that. You know what happened when I called it segments? It already existed, didn't it? And so it came right back to me. So I'm going to go Python again, and I'm going to call this a new segment. Perfect. So before I do anything, I'm just trying to anticipate the things I'm going to need. And so if I go to my menu, I want to import some modules. So if you're familiar with Python, these modules increase the functionality of the program. So I know right now that one of the things I'm going to use, I'm going to need something from my math module because I'm going to be taking the square root at some time. So I'm going to use this number 1. I'm going to go from math import. And I'm also going to do some, if I go back to my menu, in number 6 is where I get my random things. And so I'm going to go down to my random, and I'm going to import all of the random stuff. And there's one more thing I want to do, and this is down at the very bottom under the more modules. If I go down to A, I want to go to the TI system submenu. And I want to import the things from the TI system because what I would like to do is create a list of things and send them out and graph them in a data and statistics page. And that's what this will help me do. So these are the 3 things I'm going to import. And then before I do anything else, I'm just going to create a list. And just for kicks, I'm going to call this list a capital L. and it's going to be an empty list, because what I would like to do is I want to calculate all of these lengths that are done randomly, and I want to stick each of those lengths into that list L. And that list L will be what I end up graphing in the data and statistics page. And I want to do this a number of times so we can, to do a loop and do something a number of times in Python, we use a for command, and I should probably go up here to the menu, but I am just I'm so used to is it control? Is it control? Oh, it is control. For index in range of size. So I'm going to use number 4. I typically just type this in. So for I in range, and I'm just going to do this 100 times for kicks to start off. And what I want to do 100 times is I want to generate a couple of random variables. And so my first one is going to be M1, and I will show you where this exists in the menu item. So under random, I'm just going to use the random with just parentheses will generate a random real number between 0 and 1. And so I'm going to do this a couple of times. So that's all it needs. And then I'm going to have a Y1 that accompanies that. And I'm just going to type this in myself, because you can type it in. And then I want to do X2. I need to have an X2 and a Y2. And I do understand some of you Python purists are probably thinking there's got to be a better way to do all this. But I look at Python in the classroom as a way for students and teachers to make their thinking explicit. And so I know there may be some shorter ways to write these commands, but I think in a classroom, this is a good way, especially for helping students learn. And so what I have right now, I've got these random coordinates. And then what I would like to do is I would like to compute the distance using the distance formula. And I'm going to use D equals. And if you recall, I imported the math stuff so I could use this square root command. And so here's my square root command. And so in my square root command, I'm going to open up a couple parentheses, and I'm going to go 1 minus x2. And if you remember, John talked about 2 asterisks is, there it goes. 2 asterisks squared is how you square something. I'll go plus, and I'm going to go y1 minus y2, and 2 asterisks again will allow me to square that. And so this is my distance formula. So I'm going to do this 100 times. And then every time I do this calculation, I want to stick that value of D. I want to stick it into that list L that I defined up at the very top that is empty. And so to do this, there's an append command. And oh man, let me go to the menu. I know I should be using the menu more and more and more. And so there's built-ins up here in the top, and there are a bunch of list commands. And the command I want is going to be append. And how that works is in the front of that is the name of your list. And so I'm going to take my list L, and append means I'm going to stick something right in the back of that list. And what I'm going to stick is D. And then let me click out of here a couple times and do that. And I know John has talked about the little kind of gray rhombies that are there to show you your spacing, because I know this is all based on white space. So I'm going to do that. I'm going to do all of that stuff, the x1, y1, x2, y2, the distance, and I'm going to take each of those distances and cram them into that list L. I'm going to do that 100 times. And then, and so what I would like to do is I don't want to print it out every time, but at the very end, I think I want to print out. Oh, I guess it's not going to let me do that. There it is, print. Oh, well, I will go here. Ooh, and I think I want to print. I think I want. Let's see. To do the average, I would like to do the sum of whatever is in list L. and I want to divide it by how many things will be in there. And right now there's going to be 100 things in there, so I'll put 100. And I know there are Python folks out there who are probably thinking you probably should have just defined like the number of trials. Yeah, you're right. I probably should have done that. And so it's going to print out this. And then what I would like to do is I want to take this list L. I want to take this list L and I want to pass it back out of like the Python part of things and back into the Nspire part of things. That's why up here at the top I ended up. That's why I imported the TI system stuff. And so to show you how that goes, I'll go after the print. I'm going to go back to my menu. And under the More Modules is the TI system stuff. And the thing I want to use to get that list of values out of Python and into my TI kind of area is the store list. And what I've been doing recently is like I've been making the TI-Nspire name the same as my Python name so I don't get confused about which one is which. So I'm going to call that capital L. And I'm going to call that capital L. And oh, man, I wonder if this is going to work. I'm so excited. I can't wait to see what happens. And so I'm going to use the Control B to kind of build the program. Right now, there's an asterisk up here at the top of my new segment, PY. That new segment tells you that, or that asterisk tells you there's been changes and it needs to be kind of compiled and saved. So I'll go Command B. Oh, my goodness gracious. I'll do Control B. Oh, where was it at? Where was it at? Where was it at? Well, since I don't like that, I'll probably just delete that out if that's where it is. I'll come back to it later. So Control B, perfect. And let's go Control R to run this puppy. And nothing happened. Nothing happened. But what we'll see is that I'm going to add another data and statistics page. So I'll go Control Doc and add a data and statistics page. And I don't know what all these things are. I'm going to go down here and I'm going to click on L. And so those are all of the different segment lengths that were produced by this Python program. So let me go back into my program just to show you that was 100. That was 100 of those things. Let's do 1,000. Let's do 1,000. And then just for kicks, because I like to do this, I like to do things for kicks. Let's print. Let's print list L just for kicks to see what happens. I have no idea what's going to happen. And I'm going to do my Control B, and then I'm going to Control R to run it. And these are all of the different segment lengths. See, I obviously spent too much time over the weekend messing with this. I just like seeing all the different patterns that are there. But this is running through 1,000 different random segments in that Python program. 1,000 of them. And this seems escape, but it's almost over.
Just a comment here. This program would have been done almost immediately if he didn't have that print statement in there.
Yes, if I didn't have the print statement in there, if I did not, and actually it goes really, really quick. I think also being shared and having a couple of things going on is also slowing things down. But that's okay. We'll see if that'll work. Yeah. Well, there you go. There you go. There you go. I'm excited to see what happens. I'm excited to see what happens. Usually escape, but it's going to be done it's going to be done in a second. And if not, it doesn't let me do anything. Maybe I shouldn't have done 1,000, but it's just so much fun to try to do this 1,000 times and see what the dot plot looks like. There, see? Let me go here. So let me go there. And there are 1,000. Let me do a zoom data. And there are the 1,000 different segment lengths. So it's not symmetric. It's not symmetric, and I think the mean of this is probably around 0.52. I think the mean is probably in there, but I'm not going to do any more with that. That was a lot of fun. So super quick, super intuitive, and it's just a way to kind of extend. I could see using this if you're doing distance formulas in geometry, or if you're trying to do something in statistics, you want to show someone a distribution that's not necessarily symmetric and unimodal. Here is a way that you can handle that.
Steve, people are expecting a uniform spread here. Can you run it with 5,000 but take out the print statement?
I will do that. Oh man, I tell you what, man, you are living dangerously. Okay, you said you want 5,000, John? You said 5,000, man. So I will do 5,000.
Thank you.
So Control B, and now Control R, and it's done. And here is, let me make this. And so there's your histogram.
Sure doesn't look like a normal distribution to me.
No, a slight little tail down here at the end. And we could do this, and since this list now exists in Nspire, we could do all the typical things. You could go to a notes page and you could find the mean of if I was only in the math box, you could go and you could find the mean of list L. So a little more than enough. But that's again, guys, love doing this stuff. I'm going to stop sharing my screen, and I'm going to see if I can go back, and I'm going to drop this ball back to John, because John really loves this stuff here. He's got some really cool other things to show, and to really push this stuff to the limits. So, John, you've got the control again. But again, hope you have some ideas on ways you could use this in a class.
So, John, you have control. You're also currently muted, just to remind you, and you're not sharing your screen yet.
Thank you. There we go. Back to here. Okay. So Steve has this program. My screen is blank here.
Hey, John, can you double check that you're sharing your screen one more time?
Yep. Share my screen.
That looks good.
Better. Okay, thank you. So I don't have that program that Steve just wrote here, but if you get a copy of this file, Mike will provide a link to you after the session. At the end of this document, there's a problem 2, and both completed programs are included in this file. You don't have to reproduce them yourself. Here's Hero's formula that I started earlier, but this also includes the input statements down at the bottom and the print statement. So when I run this program this time, it'll actually ask me for side 1, side 2, and side 3, and print the text, area is, and then evaluate the function. The tricky part about input statements in Python is that it always returns a string. So you have to convert string values into either floating point numbers or integers using float or int if you want to evaluate formulas with them. So for this example, I use float of the input statement. I'm going to press Control R here to run the program, put in 6, 8, and 10, and it prints the area is 24. Python also includes print formatting, but we won't get into that tonight. But you can make this pretty printed in nice, neat text format using the format function. Steve's program is next, and it's what he wrote earlier, only he has trials equal 50 here. and it does the same thing that he was doing earlier. The store list command, let me talk a little bit for a few minutes about these, wrong menu here, these other TI products that are included in here. So the built-ins are stuff that's built into Nspire, into Python, but they're included on these menus to make them easier to access, and they include the inline prompts, and sometimes they include pop-up tooltips on the fly. The math menu is a Python standard module. These modules have to be imported if you want to use any of the functions in these modules, like Steve did with the square root function and the random functions. You have to import the module first, and that will give you access to these modules. The reason for having these separate modules in Python is to keep the programs as lightweight as possible. Only use the minimum amount of storage for your program. And having these modular components in Python makes Python programs very fast and very efficient. Python is used all over the world nowadays for everything from video processing to e-commerce and web development. The random menu includes the random number generator from 0 to 1. A lot of people are fond of the rand_int function and the rand_range function. There is a seed function built into the random number generator, but I almost never use it. Things seem to be random enough for me. Under more modules, there are 2 more modules that are built into Python. The complex math module, which defines complex numbers and lets you convert and extract components of complex numbers, and the time module. The time module is valuable for the sleep command. If you're familiar with TI Basics wait command, the sleep command in Python does the same thing. It pauses the program for a given number of seconds, and yes, it can be a decimal, and then the program will continue to proceed. The other functions on here are time functions, and I'll show you a demonstration of that in a little bit. So those are the 4 Python modules that are included in the TI-Nspire Python version. The TI-Nspire Python is based on a product called MicroPython. It's not full-blown Python. It's Python that's built for small devices like handheld calculators. The other modules that you see on this list, like TI-Plotlib, TI-Hub, TI-Rover, TI-System, TI-Draw, and TI-Image, are TI-developed modules to work with the TI-Nspire. They're designed specifically to use with the TI-Nspire. Steve demonstrated the TI-System module and the store list function. I'm going to pop that up again here just to give you an idea of what a pop-up tooltip looks like. Notice it says TI-Nspire list name here. And if I press the tab key, the Python list. This is always confusing to me because which one is the TI-Nspire thing and which one is the Python thing? And here the tooltip pops up and lets you know which one is which. That's a time saver and a lifesaver for me. More often than not, we choose to use the same name for both environments. But the Python world and the Nspire world are 2 separate entities in terms of variables. If I press the var key right now, I'm in the Python editor. It shows me the names of the variables that are defined at this point in the program. Lengths and trials. Lengths is the list, trials is the number of trials. What happened to X1, Y1, X2, and Y2? Well, they're in here, inside the function. So if I press the var key now, I should see, why don't I see X1? Oh, because they're inside the function. Where's I? I is a local variable too for this function. So these variables are in the function, they're not in the program. All we see outside are trials and lengths. In the shell, if I press the var key, I see all of the variables that are defined in this shell. These look like my Heron's formula variables, X, Y, and Z for the size of the triangle, and Heron for the name of the function. So the shell and the editor contain different variables depending on which environment you're working in. We're getting down to the wire here. This was one of Steve's examples. Let me go back to the beginning. And here's some extras. What happened to, there it is, geometry graphics demo. So in this demo, I'm going to show you, I'm just going to run the program, I'm not going to write it for you, but it uses the draw commands, which are the same draw commands that you get in TI Basic. You can draw rectangles and circles and lines and polygons. The random number generator is used to create random circles. And the TI system menu is used for this while get key is not equal to escape. The escape key is used to break out of many, many, many programs. And this is built into the menus all over the place. If I press menu, more modules, and look at TI system, you'll find while get key is not equal to escape on this menu. You'll also find it in the rover menu under commands, while get key is not equal to escape. You'll find it on the TI Hub menu, which is used for the TI Innovator, under commands, while get key is not equal to escape. So this is a very useful command to stop a program from running by pressing the escape key. So in the demo, it generates random circles in a random color and keeps going until I press the escape key. If I press Control R, it's not going to look too good over the video, but a bunch of circles are being produced at random on the screen. But they all seem to be pretty red, but not quite exactly red. If I press the escape key, the program ends. Notice the title bar says finished, but the screen stays on there until I press the key, any key again, and it goes back to the shell. Going back a page and back into the code, you can see why it's only red, because I have one number, C, in the range from 0 to 200 to 255, sorry, but it's only controlling the red segment of the color command. There's also a green and a blue channel that can be controlled as well. If I put the letter C in here for a blue channel as well, then I'm going to get a combination of red and blue. When I run the program, I get purple circles. And this will keep running until I press the escape key. What happens if all three colors are the same value? What color would you expect? Gray. Let's see if it's going to be gray. And it is. And the one that bugs me the most is what happens if I just use red and green? Waiting for an answer. No guesses? Cyan, let's try it. Press Control R. For the life of me, I can't figure out why red and green make yellow. That's a mystery to me still to this day. But it's true. Cyan would be a combination of green and blue. Orange is a mixture of red and green, but not in this equal amount. You can get orange by mixing some red and some green, but not evenly. So this is a kind of program that can be handy for kids to explore the combinations of colors. We can also create extra variables in here. We can have a red variable, a green variable, and a blue variable, and then get all kinds of random colors in here. So the editor is very handy to come here to be able to copy and paste. If I select this text using Shift down arrow, I can hit Control C on my keypad, and then I'll hit Control V twice to paste it in. And we'll make this one G and this one B. And in the set color command, use a G and a B. and then we get lots of random colors. But they're all going from the random number generators going from 200 to 255, so the colors are kind of pastels. By the way, each circle has a black circle around it to make them stand out better, and that's done in the last command down here. Set the color to black and just draw a circle with the same radius as the filled circle. The other demo I wanted to show off is the time demo. A lot of people about 2 or 3 weeks ago during a webinar were hung up on this time thing. And what we finally learned in the Python world is that both the computer software and the handheld have a built-in clock. And you can tell time on a TI-Nspire handheld. If I run this program, notice the important line in here is this one, which is really one long line. The function local time that you may have seen in the time menu produces a bunch of numbers: the year, the month, the day, the hour, the minute, the second, the day of the week as a number, the day of the year as a number, and whether or not it's daylight savings time as a 0 or a 1. And the values that I'm most interested in for this demonstration are the hour, the minute, and the second. So this creates string values out of each of those and incorporates the colons to separate them into this variable called time, T. Clear the screen. Isn't that familiar? Anybody ever programmed in BASIC back in the 1960s? CLS is back. It clears the screen and draws a text at line 7 on the screen in the center, and the text that's being printed is the time. So when I run this program, the time is now 20:51:55, and that corresponds, if you look at my computer time, I'm in the Eastern time zone, so it's 8:52 p.m., 20:52 p.m. Can we import external modules? It depends on whether or not they're compatible with the TI-Nspire environment. NumPy and PY, and what was the other one? Plotlib or PY? I don't think they are compatible with the TI-Nspire MicroPython environment. But that's what the TI Plotlib is used for. I'm going to hit escape here to stop this program. And one more demo in here. Oh, with a clock program, we can write timer programs. I know you're not seeing this, but this is going by at 1/100th of a second, and it's ticking off the seconds. This is a stopwatch type of program. If I hit the space key, it pauses the display, but the clock is still running in the background. So if I hit the space key again, you'll see the time jump up quite a few seconds for the current timer. And if I press enter, it'll stop, and enter to reset. And that's a stopwatch. One more program to do with time is this one. So Bert Wickering from the Netherlands wrote the clock display, and I wrote the rainbow colors in the background. So it's probably kind of jumpy coming across on the WebEx environment, but the colors are scrolling smoothly in the background as the second hand is ticking away. So there's a lot of cool stuff that you can do with Python. This weekend, I wrote a new program without using any modules at all, no import statements whatsoever. And I finally got it to work properly. But it's a guessing game involving, what am I thinking? I'm thinking of something, and the computer has to guess what it is. But it learns as it goes. So it was a lot of fun. Handout. As Mike will also share a link to this document. It's 7 pages of introductory materials about the Python environment on the CX2. We wrote this back in the springtime for newcomers or users of TI-Nspire and the Python environment. So it's a 7-page document, new to Python, experience with Python, for beginners, a first program, etc. So this document will also be available for you to download in addition to the TI-Nspire file. We're running close to time up, so I'm going to pass the ball back to Mike. And thanks for your time. Oh, I forgot one page. Mike, you have this file?
Well, let me give you control back. Give me 1 second.
Yeah, I forgot about the references in there.
Go ahead and share your screen again, John.
In the TI-Nspire document, wrong document, this one, there's other resources, and most of these links are videos. T-Cubed Europe did two hour-and-a-half sessions a few weeks ago on the Python environment for the European community. There's a YouTube video by Fred Foch and Becky Beyer on introductory Python. This one I found very useful by Jennifer Vermillion on introductory Python stuff, but it's not a TI product. And up at the top is a blog post by Harshal Chaya, one of the TI managers of this project. And he just wrote why Python is so important in teaching math, science, and computer science these days, because it's ubiquitous in the world. You'll also have our email addresses as part of this TI-Nspire document, or you can copy it from the screen in this recording. Back to you, Mike.
Thanks so much, John and Steve. One thing I do want to share from our website, education.ti.com. If you visit our website on any page, on the bottom right-hand corner, there's a Contact TI link. And if you click on that and click on TI Sales Support, this will bring you to a list of contacts for your educational technology consultant. If you don't know what a educational technology consultant is, the way I like to describe them is they're a set of people that work for Texas Instruments, and they are a great intermediate person between you in the classroom and your needs, and what Texas Instruments is able to offer as a big company. So a lot of these people are former educators and know quite well what you're doing within the classroom and what your needs are. So reaching out to them either by phone or email is usually really helpful, especially right now because there's currently a syllabus campaign going on. So any educator who shares their syllabus with an ETC in which it states that they recommend students to use a TI-Nspire CX family or the TI-84 Plus family member will receive a free license to the TI-Nspire CX Premium Teacher software that John and Steve were both using tonight. So please feel free to, again, visit our website and get in contact with your local ETC if you haven't talked to them recently. Go ahead and share a copy of your syllabus with them, and that's one way to get a free license for the software.
That's a permanent license.
Correct. Not a trial version, but a permanent license. You can get a trial version tonight or at any time by visiting our website. And on the right-hand side, if you visit distance learning, you can go and see the options that we have for the current situation. And lots of trial versions are available for different TI software products. To receive a certificate of attendance, please go ahead and click the link in the chat window. Also, is linked as promised for the documents from John and Steve that they put together for tonight. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificates. If for any reason those links aren't working for you tonight, hang tight. You'll automatically get a follow-up email in a couple days. And that follow-up email will contain links to the recording so you can watch this at your own pace, the certificate, and the documents as well. if you have any questions after the webinar, or maybe some questions that weren't answered during the webinar, if they are Python specific, feel free to reach out to John and Steve. If they are more general and TI specific, feel free to give TI a call at 1-800-TI-CARES or drop them an email, ti-cares@ti.com. Big thanks to John and Steve for everything they shared tonight. It's exciting what this is able to do. So thanks so much for spending a little bit of time tonight with us.
Bye, everybody.
See y'all.